So I want to put a little bit more time into understanding this value. Again, the standard deviation gives you an estimate of the average distance from each data point to the mean. Now, how does this relate to spread? Well, data sets with more spread will tend to have values that are further away from the mean or the center of the data. Now, the mean is not technically the center, that would be the median, but you can think about the mean as one way of thinking about the center. So the more spread you have, the more you're going to have values that are further away from the mean. And when you have values that are further away from the mean, that's going to make your average distance calculated by the standard deviation larger. If you're further away from the mean, you've got more spread and you're going to have a larger average distance from the mean. So more spread in the data means that you're going to have a larger standard deviation because you have more spread. The values are further away from the center, therefore you have a larger average distance. So more spread in the data means a larger standard deviation. Less spread in the data means a smaller standard deviation. Again, less spread means that you have data values that are closer to the center. And if the values are closer to the center, they're closer to the mean. So your average distance to the mean is going to be smaller. So less spread in the data means a smaller standard deviation. Let's look at that example we had from when we did that calculation by hand of the standard deviation. We had 9 data points on these hold times, 24, 25, 25, 26, etc. So these are the 9 data points. The mean was 26.8 minutes, and the standard deviation was about 2 minutes. That was with these 9 data points. If a 10th hold time of 12 minutes was added to the data set, let's think about what would happen to the standard deviation. Would the standard deviation increase or decrease? Well, think about where 12 is related to these current 9 values. 12 would be much lower than the rest. So 12 would make the data set more spread out. This would spread out the data if we had one more hold time of 12 minutes. So the data set would be spread out more. And if your data set is spread out more, remember, more spread gives you a larger standard deviation. So this means the standard deviation is going to increase. Because that value of 12 is going to create more spread in your data. All right, what if we had a different value? Instead of 12, let's say our 10th data point was 26 minutes. Think about where 26 is. 26 would be right kind of in the center of that data. So what you have is a value that's close to the mean. Remember, the mean was around 26.8, so it's close to the mean, and it's creating kind of a more packed data set near in the center. So that means you have less spread. In other words, more packed data. More data packed in the center. So because you have less spread, the standard deviation will decrease. And we're not actually calculating the standard deviations here with this new 10th data point. We're just thinking about, based on what standard deviation means, what would generally happen. In this case, a value that is a long ways away from the mean, so out on the edge, is going to create more spread. Like that 12 minutes is out on the edge of the data set. It spreads out the data set more, so your standard deviation increases. Whereas if you have less spread, the data is more packed together, as we had with 26 minutes, the standard deviation will decrease. Okay.